Okay, thank you very much everyone for joining on the second Skopje Tech Talk event. This time we'll have the pleasure to listen to Boris Siljanovski on a very interesting topic. We just had a very small chat about that offline without the camera turned on. Now we are online, so without any further ado, I will just give the microphone to Boris. Boris, you can just feel free to introduce yourself in any way you feel it's necessary in the presentation. I will just switch off my camera during your presentation, and for everyone in the audience, if you want to ask a question, you can just chat directly to me so I can unmute you, or type the question in the chat and we'll pose the question after the presentation is done. If Boris has no problems taking questions during the presentation, we can also interrupt you, but that's
yeah, sure, that's not a problem.
Okay, so yeah,
because how its concept is, first I'll give basically a theory behind how it works, and then I'll create one demo app and show one more app, just so we can see the patterns that are available to us. And at any time, if somebody wants to ask a question or something is confusing for them, feel free to let them ask.
Okay, then I'm switching off. Boris, the floor is yours.
Thanks. So hi everyone, my name is Boris. I'm a senior software engineer in ScaleFocus, and today we're going to be talking about creating parsers and using Antlr for doing so. So on the agenda is basically introduction to Antlr and how it works, how the grammars are written for Antlr, and then comes the fun part where we will make one application that's a basic calculator app where you can input calculation, and then it will give back the results. And then I'll show one more application, which is a highlighter app, which basically parses the input, a source code file, and marks the keywords in different colors, comments, strings, and etc. So what is parsing? Basically, parsing means taking a stream of text and breaking it into meaningful chunks. Basically, it's vital to turn the code written in some language in a computer that in a way that a computer can understand it. Parsing in general is turning written language into meaningful thing, and we do it all the time. For example, when you read this slide, your brain parses the information, the text that is shown on the slide, and basically that's how you understand what's going on. With parsers, basically we can build all kinds of valuable tools like code converters, domain-specific language interpreters, Java to C# translators, HTML parsers, and of course complete compilers. As a programmer, you may ask yourself, why can we use just regular expressions like we, I guess, always do? And regular expressions are useful most of the time, but they have some limitations. And some of the limitations are lack of recursion. They are unmaintainable. So basically they can blow up in size really fast, and after a day or two, nobody understands them anymore. They are also not scalable. And I don't know if you ever tried to parse HTML with regex. So let's show an example. We want to parse an HTML table with regex, and we start with basically the table tags and match everything in between. But then we realize that the table attribute can have style and ID, or basically it can have attributes inside the tag. Okay, so we covered that case as well, but then we realized that we have rows and cells inside of the table, so we need to care for that specific case. And then we realized that we have comments as well in the HTML. And basically, once we are done with the whole regex thing, we might end up summoning Cthulhu, the demon. So how we can avoid this? Basically by using Antlr. And Antlr is the abbreviation of another tool for language recognition, and it's a parser generator. What that means is it's a tool it's a library that generates parsers for you. A parser is takes a piece of text and transforms it into an organized structure. And also Antlr is used in the real world. Some of the biggest tech companies use it, like Twitter and its search API, use it for query parsing. Oracle uses it in the IDEs of the SQL developer tools. NetBeans parses C++ with Antlr, and so many others. So how does Antlr works? Basically, to start working with Antlr, we create a formal language. Basically, we create grammar files, and Antlr parses those grammar files, and from that grammar, it knows how to process the text and build parse trees, which are data structure that are representing how the grammar matches the input. Antlr also automatically generates tree walkers for you, so you can basically start walking down the tree and react upon the nodes that you encounter along the way. So to implement a language, we need to build an application that reads sentences and reacts appropriately to the phases and the input symbols it discovers. And basically, a language is a valid set of sentences, which then the sentences are a valid set of phrases, and the phrases are made of phrases and then vocabulary symbols and so on. So if an application computes or executes sentences, we call that application an interpreter. And if we are converting the sentences from one language to another, we call that application translator. So the interpreter or translator must recognize all the correct sentences, phrases, and subphrases of a particular language, and as I said, act appropriately. So basically, recognizing a phrase means that we can identify the various components and we can differentiate them from the other expressions. And as I said, programs that recognize languages are called parsers or syntax analyzers. And here, syntax refers to the rules governing the language. So parsing is much easier if we break it down into two similar but distinct tasks or stages. So the separate steps mirror how our brains read the English text. Basically, when we read some text, we don't read the sentence character by character. Instead, we perceive the sentence as a stream of words. And basically, the human brain subconsciously groups character sequences into words, look them up in some internal brain dictionary that finds their meaning, and then afterwards it's recognizing the grammatical structure. So the process is more evident when we are reading, let's say, for example, Morse code, because we need to read the dashes and the dots, then convert them to, basically group them first, then convert them to real words, and then understand what somebody that's sending the Morse code wanted to say to us. So yeah, basically, when we start parsing something, we send the input of text. And as I said, that text is a group of characters. And for every, so if we want to understand the words that are in the set text, we need to somehow group the letters into meaningful words. And the process of grouping the symbols into words or tokens, it's called lexical analysis, or simply tokenizing. So we call up the program that makes the tokenizing. We call it a Lexer, and the Lexer can group related tokens into token classes or types such as integers, identifiers, floating point numbers, and so on. The Lexer groups the vocabulary symbols into types, and then the parser carries out their meaning in the context in the whole sentence. The second stage of the parsing is actually calling the parser, and basically once the Lexer is done with recognizing the words that we're gonna find in the input text that we're gonna send, then there comes the parser and basically understands how the words correlate to each other. And after it finds how the words work with each other, then it creates the parse tree that represents the whole structure of the text. So basically, the parsers that Antlr generates are called recursive descent parsers. And basically, those the recursive descent parsers are just a collection of recursive methods, one per row. This descent term means that we start from a root node somewhere up in the tree, and then we work our way down. So basically, the root that we invoke first is, the start symbol becomes the root of the parse tree. Once we compile the grammars, the Antlr tool will generate some code for us that we can later use to in our actual code to work with the parse trees. And there are two patterns that are available for us out of the box provided by Antlr, and the first one is the listener pattern, and the other one is the visitor pattern. So the listener pattern is basically we walk the tree and listen for events. Basically, when the tree walker finds a node, enters the node, and when the exits the node, and basically it triggers an event. On the other hand, the visitor pattern basically walks the tree, and once we encounter a node, it invokes the appropriate function, and then we somehow process it depending on what we need. And after that, we move to the children and so on. So here's some simple syntax that can be used in the Lexers and the parsers. And basically, the Lexer and the parser have similar structures, and that's why the Lexer symbols, we write them in all uppercase, and the parser keywords, we write them in camel case. So basically, we have punctuation, keywords, ranges, and patterns, and we're gonna explore them in detail, more in detail once we get to the demo application. We also have fragments, and fragments are reserved keywords that basically mean that the syntax that is marked with fragments will only be used in the lexical context. We have we have the skip command, and that basically means that we don't want to parse some type of tokens that we encounter, and that's most often done on white spaces, new lines, and so on. The parser language patterns, on the other hand, are a sequence, basically a sequence of tokens that are counted in series. We have a sequence with a terminator, basically a statement that ends with something with a separator, group of tokens that are separated by some value. We have a choice, basically an alternative phrases. For example, a type can be either integer or float, and some statement can be an if statement or return statement, a while statement. Also, we have a token dependency. Basically, we can invoke the presence of a one token requires the presence of another and more subsequent tokens. And also there are some nested phrases and recurve. So it's demo time. And I'm gonna open my editor here. And the first program that we're gonna be doing is a simple calculator app. And to start, we first need to install two NuGet packages. The first one is Antlr4 code generator, and the second one is the ANTLR runtime. The code generator basically analyzes the grammars and creates the classes for us, and the runtime is basically what executes the code. So I'm going to create a folder here that I'm going to call Antlr. And in there, I'm going to create two files. So first one will be calculator G4. So the G4 is the extension for the for Antlr classes, and I'll create one more that will be for as well. So we're gonna first start with creating the Lexer grammar, and we start by defining what type of file is this, and this is a Lexer. So we're gonna say Lexer grammar and the name of the file. Then we're going to define, because we are using a calculator, we're going to define the symbols that we might encounter in some of the calculations. So let's start with the plus sign. Then we have the minus sign. Then we have a star, which is a multiplication. Then we have a slash, which is a division operator. Then we want to have parentheses as well. We define them as well. And now we have to define what constitutes an integer. So in this case, I'm going to call the integers int. And basically, the integer can have negative sign, that is an optional. And we can use the question mark, that means 0 or 1 occurrences of something. Then we're going to specify a range of numbers that's between 0 and 9, and we can use the plus sign, which means 1 or more occurrences repeat. And also I'm gonna create a double as well, and the double, same as the integer, can have a negative sign that is optional, and then it can have a range between 0 and 9 that repeats 1 or more times. Then a decimal, a double can have a decimal point, and then one more occurrence of number ranges after the decimal point. And then we can, because we don't care about white spaces, we're gonna put them, we're gonna skip them basically. So for white space, it can be white space, the tab operator, the new line, and the Windows thing. I forgot the name. Okay, so I think we are done with the grammar, and we can move to writing the parser. As in the Lexer, we need to define what type of file is this. So this is a parser grammar, and the name of the file. Then we need to specify some options. And by options, we say that which Lexer file this parser is going to use. So we say token vocabulary equals calculator Lexer, and then we can start actually writing the parser rules. So when I write the parser rules, I start from the bottom and work my way up. So the first thing will, and let's say I'm gonna write some expression here just as a guidance, so I know what I need to parse. And then going from the bottom to the top, I realized that we have a constant, and that's basically a number, or it can be a decimal number if there's a decimal point. So I'm gonna specify constant, and that constant can be either integer or, using the alternative sign, double. Then after that, we need to have some operators, whether it's the parentheses, the multiplication, addition, division, and etc. So I'm gonna call that rule expression. And then I'm gonna write a bunch of alternatives, and I'll explain them in a minute. So we can have expression, then sign in between, so star or division, and expression on the other side, or I can have expression again with addition or subtraction. Then I can have a constant, or I can have parentheses. The parentheses inside of them have an expression as well. So when we are writing the parser, we can either use an implicit or explicit rule. So basically we can define the parentheses like this because it's much easier to write, but it's not wrong if we specify the parentheses like parent open and parent close here. But I like more this direct approach because it's much easier to read. So what happens here? We are basically using a recursion, and we specify a bunch of alternatives. The constant here is basically the return statement of the recursion. So basically, once we reach a constant, the recursion will end, and it will start working its way backwards. But an expression, if we see this this expression here that we have, it can have a star sign, which is multiplication, and a plus sign, which is addition. And here, the most important thing is that the multiplication has operator precedence before the addition. But in the eyes of Antlr, these are all expressions. So this is an expression, and this is an expression as well. So this is something that the creators of Antlr and parsers in general call an ambiguity. So these two are basically the same for Antlr. But how does Antlr resolve ambiguities? It finds the first match, and that match will be the first rule. And since the multiplication and division are first, and after that it's the addition and subtraction, that's how we get an operator precedence. So the multiplication will be executed first, then the addition, and if there are parentheses, the parentheses will be executed first, then the multiplication, then the addition or subtraction, and we'll need one main rule called calculation, and that will be an expression that executes one or more times. And if I copy this expression and set this rule to be tested, and if I paste that expression here, I'm going to see the syntax tree. And for the time being, I will move the parentheses just so the tree is more simple. And we see here that when we walk the tree, we'll first execute the multiplication, and then the result of that will be the addition. And once we get back the parentheses, we see that the first will enter the parentheses, then we'll resolve the inside of the parentheses, and then we'll do the division as it should. Okay, so right now, moving on, I'm going to build the project once. So, and if I go to the Explorer and into the object folder and debug, I can see the generated classes that I can use. And if you can see here, the names are basically the same as we define them in the starting rules of the grammar. Then we can proceed to create our own visitor. I'm going to call that calculator visitor, and this class will inherit from calculator parser base visitor, and in the generic brackets, we're going to define a double that will be returned. So once we do this, we have a bunch of classes, methods that we can override. To make my life easier, I can put labels on every operation. So this operation, I'm going to call it muldiv, which is multiplication and division. Then the next one I'm going to call sub. And the next one I'm going to call const. The last one I'm going to call parentheses. And one more thing to make my life easier, I can put labels. So if I don't put labels, I'm going to need to basically in the context when the rule is invoked, I'm going to need to get the expressions with indexes, but I don't want to do that. So I'm going to specify labels. So this one will be left. This one will be called OP for operator, and this one will be called right. And same in the second one. Left, OP, right. We'll do one more time. Then I'm going to go back to the calculator visitor, and I'm going to override a bunch of methods. First one I'm going to override is the multiplication or division. So override, and you see the method got the name from the label that I've put here. And first I'm going to take the left part and say visit the left side of the tree. This left is the label that I've put for left, and I'm going to do the same for the right side. And then once this executes, I'm going to check the operator, and I'm going to do that with context.op.type is equal to a bunch of constants here, and we can find the star. If it's a star, then we're gonna return left times right. And if not, we're gonna return left divided by right. Okay, one row down, moving to the next one, override. It's up, and it's basically the same, except for this is a plus. This is a plus here as well. Minus. One more thing I need to do is when we encounter parentheses, we're going to return basically we're going to ignore the parentheses and move to visit the children of that node. And one more thing is when we encounter a constant. And when we encounter the constant, if the context.integer is different than null, then we know that the constant is of type integer, and that's what Antlr decided it's going to be. And if that's the case, we're going to return and first convert it to int32. Text, we're interested in the text. And if the context is double, same thing. And if it's none of those, return 0. And with this done, we have everything that we need. Now we're just gonna write some boilerplate code to start executing the application. So I'm gonna specify the expression here. I'm gonna take the expression from before, this one. And here it doesn't matter if we have spaces or not, because we told the Lexer to skip the spaces. We don't care about them. Next thing, once we have the expression, we need to parse the input text in something that Antlr understands, and that's called ANTLR input stream. So var input stream and we pass the string. Next thing, we need the Lexer. So var Lexer equals Lexer and we insert the input stream. Then we need something that is called common token stream. And this also cleans the process tokens a bit more. And finally, we can create the parser. Because new parser. And once we create the parser, we can actually create our visitor that we just wrote. So our visitor and the visitor exposes a method called visit, and from the parser we're gonna invoke the expression row, one that we defined as an entry rule, and this visit will return a double, which will be our result, and then just bring that to the output. And fingers crossed, if I run this, I get 15. And let's ask Google because Google knows best. Yep, it's 15. So that's how easy it is to create a calculator application.
Boris, just before you continue, I don't know whether you're able to read the questions while you're doing the presentation, but Veko has a question which was relevant.
I don't see the chat, so I'm not sure. I was waiting for an interrupt. Sorry.
Yeah, well, I'm interrupting you. Can you see the chat so I don't read it?
Unsigned integer 32 or 32? Well, it's an integer 32, not because in the Lexer I've defined it as with a sign, so it's a signed integer.
And again, if anyone wants to enter into discussion, just write in the chat, and I will unmute you if you feel better like that. Yeah, please continue.
Just unmute the because I won't be reading the chat, so please just interrupt me so I can answer the questions. Where exactly? Oh, sorry. My bad.
I just enabled everyone to unmute themselves. So if you want to discuss, just unmute yourself and join the discussion.
And the other application that I want to show is a C# highlighter. And basically, I'm taking some input text, which is from a project that I worked on, nothing fancy, and basically mark the keywords or comments or strings in a different color. So a great thing about Antlr is you have basically for most of the languages, the grammars online. So if I search for C#, or here we can find the Lexer and the parser, but these are for the whole C# language to be parsed. And basically I took this grammar file and deleted everything except for the comments, the white spaces, keywords, and some arbitrary literals that I need here. And also, since C# understands Unicode, basically you can write Unicode code. There are a bunch of fragments that are for Unicode, and basically I have no idea what these are, but I think that they cover the whole Unicode range. So it's a good idea just to copy paste them from somewhere. This is a good starting point. And in the parser, I have a entry rule that is called program. And I'm gonna I guess it should. Let's see. There might be a bug here. Let's see if this will be an epic fail. Yep. And going back to the highlighter, we have a keyword, a literal, a comment, and rest is basically the rest of the code that we don't care about. And rest is composed of white spaces, identifiers, open brace, close brace, and something, I call it something, which is basically anything that doesn't match the before mentioned rules. Then we have a literal, which can be Boolean, string, numeric literal. And then we have they are basically numeric literal integer, hex being real, then Boolean is true, false, string literal is interpolation, or regular string, or verbatim string, and basically all the keywords listed that I can think of, and also the comment part. So this time, instead of using a visitor, I decided that I'll use a listener. And for that listener, in the constructor, I'm accepting a string writer where I will write the HTML in. And it was the easiest way to use HTML, so that's what I chose. And it would be better if we used this grammar with JavaScript, because I think I didn't mention, you can, there are ports for basically every major language and Antlr. So instead of C# you can use Java, JavaScript. I think Golang is covered, PHP as well. So yeah, basically you can use whichever language you're most comfortable in. And so once I enter the prog rule, and maybe if I open this on the side, like so we can follow what's going on. So once we enter the prog file, this is the entry file. And we're gonna write the HTML head, meta tags, title, and the opening of the body tag, and some CSS. Basically, this CSS is to match my editor colors. Then once we enter the keyword, we're gonna write a span tag, and then we're gonna read the text for that rule. And once we exit the keyword, we're gonna close the span tag. The same thing happens with numeric literal, then string literal. Only the colors are different, and you can see the colors on the left hand side in the gutter. And once we enter the rest, we're just gonna write the text. And if I execute this, just one more thing, the entry code is basically, I have input txt file that I'm gonna read the whole text from it. Then I'm gonna do basically the same thing as I did on the other project, but this time I'm gonna use a parse-tree walker, and this basically walks the whole tree and triggers events. So I'm gonna create the highlighter. Basically, that's the listener, and I'm gonna invoke the walk method in the walker with the syntax highlighter. Basically, that's the listener and the entry rule, and then I'm gonna create a directory and write the text that will be written in the string writer. And if I go to output and generated HTML and basically open that file, you see the keywords and the strings and the comments are colored like my editor. I think I matched the colors. So yeah. Here. That wraps my presentation, so I'll be ready to answer some of your questions.
Yeah, thank you, Boris. That was yeah. You look exhausted now.
Yeah, too much talking. I haven't talked in a while.
Yeah. Okay. So let's go back to the first side of the demo. Weko has a follow-up question. So you can just go to the chat so I don't read it out. So
yeah,
5
I think
plus
I answered.
minus 5.
I answered that
yeah.
question. 5 plus minus 5.
Yeah. So the thing here with parsers in general is that you really need to know what you're doing from, I would say, the domain, the user point of view. So you really
yeah.
need
So
to be careful.
I'm gonna say I'm not an expert on this topic. I just found it once, and it looked interesting to me, and I started meddling with it. So there's more to it. People are doing some crazy things, and there's the book. There's one book from the creator of ANTLR, and I think that's the de facto book. So anyone who wants to work with ANTLR should read that book. And basically, in that book is explained everything, and through examples. So, as I said, I'm no expert on this topic. I really like this library, so I thought I shared with the community.
Yeah, that's great, but I would push that argument even further in a different direction. I mean, it's not that parsers are that difficult, since anyone can learn them whenever they need one. So the question there is the domain well specified so you can extract the rules, or are you able to follow diligently everything so you're able to extract the rules of the problem that you're resolving? So here we are discussing about a calculator and a parser for code, which are two problems that we are perfectly understand, every one of us. But if you go in some domain when you have to code some grammar in general that it's does not make much common sense, then you really need to be diligent and focused to do that.
Yeah, basically you need to understand what you're doing, and you need to understand how the trees are built and what goes first after the next. And it's basically you can slap a bunch of rules and then try to parse them, and you'll figure out that it doesn't work the way you like, and then you need to debug it. And basically, since it's a tree, the debugging is somewhat difficult because, you know, it's a recursion and it goes from one place to another, to another, to another, and it can go indefinitely that way. So yeah, it's a bit hard, but I think, as I said, I started using ANTLR when they told me to write that template engine, and they were using regular expressions, so it was pretty limited, the first version. So I think I did a great job. And yeah, as I said, I'm sad that I couldn't make it open source.
Yeah, guys, if you have questions, you can just unmute yourself or type them in the chat. I will just follow a little bit on that recursion that Boris just mentioned. As far as I remember, we learned this stuff at university. So one simple question, did you remember? Do you remember something that we learned about this in university? Did you use some of it, or?
No, just walking the trees, and I know well, in university we learned about binary trees. This is not a binary tree, but it's somewhat similar. And walking the trees, basically you're a bit familiar with trees and stuff like that.
Yeah, for sure. But yeah, the theory that people usually learn in university becomes useful many years after that. Sometimes, not always, I would say, sometimes. The thing is, we usually don't remember that until we reach that
basically
point.
From universities, when you see the tree, you don't get scared.
Yeah. Well, it depends who was your teacher. That's also really important. Okay, I see that there are no more questions from the audience, so that means that we can bring this to an end. Boris, thank you very much for sharing your knowledge. As I said, these events are great.
Thank you.
We need to stimulate all community around here and people to start sharing knowledge. This session is recorded and will be available online for everyone if they want to follow up after some time. And whoever is interested to join and contribute in any way related to technology, just feel free to reach out, and we'll discuss whether and in which format that would be possible. Thank you guys for joining in. Again, thanks Boris, and see you very soon, hopefully very fast after the holidays. Have a great day, everyone.
Thank you.
Bye-bye.
Bye, guys. Thank you for coming.
Bye.